Hello, my name is Josh Carloni. I work for New Hampshire Fish and Game as the lobster and crab biologist, and wish I could be there with everybody, but it just wasn't in the cards. But anyway, super excited to be able to share this research. Glad I have this opportunity. First, want to point out the co-authors to this work. We hope to submit this for publication within the month. Of course, I I said that about 6 months ago when I last presented this. So, but I think this time we're on the right track and ready to go. And so, what I'm going to present to you today is phenology of lobster larvae and Calanus finmarchicus over a 30-year time period off the coast of New Hampshire, and looking is there any evidence of match mismatch with these two species. And so first, this is a figure directly from our 2018 paper. I know Rick has introduced some of this, but there's just a little couple points of clarification that I'd like to make here with this figure. So what you're looking at is the abundance of post-larval lobsters from a Newston survey and Calanus finmarchicus from an independent zooplankton survey. And you can see these match each other really well. They follow each other over this 30-year time series really well. You can see the detrended correlation there at the bottom. This is one outlier from a year with only a few samples. But generally, they track each other remarkably well. And so this did not suggest to us that this might be a critical food source for post-larval lobsters. And that is for a couple of reasons. So one is these guys have a high resistance to starvation. This is the final larval stage. For those of you outside of the US, not as familiar with American lobster, there's 4 larval stages, 1 through 4, and 4 is kind of more commonly referred to as the post-larval stage. But anyway, these guys have a high resistance to starvation. And not only that, in this 2018 paper, we found a strong correlation between what was sampled in the Newston and what was sampled on the bottom with scuba surveys in an independent survey for young of the year lobsters, suggesting that there's not a high mortality rate, at least once these guys make it to these near shore settlement areas, where kind of both of those surveys take place. But what it did suggest to us is that these early stage lobster larvae that need high quality, high abundance of food to metamorphose to subsequent stages and finally make it to that post-larval stage. So what it suggested to us is in years of high abundance of Calanus, you're going to get high success rate of making it to that post-larval stage. And in years of low abundance, as we're seeing in these most recent years, you're going to have a low success rate making it to that post-larval stage. And so I just kind of wanted to set the stage here because this ties into this current work that I'm going to present to you today. And so what you're looking at here is the phenology of, first is the timing of egg hatch. And this is from our sea sampling program, where we go out on a monthly basis from May through November, and we ride aboard with commercial harvesters and track their catch. And we also track several different egg stages, and one of those is when eggs are hatching. And you can see this is the proportion of total eggers in the month of June that are hatching. And so you can see early in this time series, you're more around 10, 15, 20% hatching of all the eggers. And as you move into this time series deeper into the 2010 range, you can see that a higher percentage, up to 40, 50%, even higher in some cases, are hatching in that month of June. So this is a significant increasing trend. And then at the bottom, what you're looking at is the Newston survey, and this is first appearance of stage 1. You have week a year on the y-axis, and you can see this declining trend, which is showing that as this time series goes on, these guys are showing up earlier and earlier. And both of these correlate well with those spring temperatures, April through June. This is the phenology of Calanus finmarchicus. And so what you're looking at here, I'm going to draw your eye to this first panel. This is the beginning of the season. So this is when abundance for the entire year reaches the 25th percentile. And you can see that this varies without trend over this 30-year time series. Bringing your eye down to the end of the season, you can see that the end of the season, there's a significant downward trend here. This kind of most recent decade, you can see this is ending earlier than it did in the past. And then season duration, or duration of the season, again showing this downward trend. And again, your eye is kind of drawn to this most recent decade here. And so the next question becomes, well, what months are likely important? That's showing that Calanus season is ending earlier. The season duration has been truncated. But what months are likely important for lobster larvae to have this food source in the water? And so what this is it's the correlation between post-larval lobsters and Calanus, just like we did in our 2018 paper, only this time we ran it by month. And the months that come back as significant are July and August, which makes sense. These guys, start to hatch in June. There's a month-long larval season. They hatch through July and a little bit into August. And so that's kind of looks like that critical period where these guys are going to need an abundance of food to make it to that post-larval stage. So if we come back to this figure that I showed you, which is end of the Calanus season, which is when it reaches the 75th percentile, if I did not mention that. And then these are time periods on the y-axis. These were collected in 2-week blocks. So these are time periods of 2-week blocks. And then if we add July for reference here, kind of, that time period when it would be very beneficial to have this food source in the water. If you draw that line, you can see you follow this time through. It's ending, after July, around July. You see this period here, which was a high decade of recruitment in the Gulf of Maine. Calanus season is ending after July. And then again, look at this most recent decade here. It's ending well before July, the Calanus season. And in many cases, as I said, well before. So the next question is, how do these guys, I'm going to move myself around a little bit here so you can see everything. So the next question becomes, well, how do these guys overlap on a temporal scale and looking at this over this 30-year time period? And what I did here is I took a Berth et al. It's the mismatch index from a Berth et al. Paper, and I modified it to fit with lobster. And so this is it's a rather simple equation, but it takes some explaining. So if you look at this, you have positive values here, negative values here. Positive values are going to be a positive overlap between these two, and a negative overlap. And I drew these little schematics to try to visualize this. And so positive overlap would be Calanus season is going on. Within that season, you have stage 1 peak within the Calanus season. And then you take that number for when the season ends, and you subtract it from the peak value for stage 1, and you get a number of weeks. So for instance, if we come over here, this is around 9 or 10. So this is saying that Calanus season ended 9 or 10 weeks after stage 1 peaked in the water column. Here's a mismatch, an example. That would be Calanus season comes, it ends, and then after that, you have this peak stage 1. And you take the value for Calanus, subtract it from the peak stage 1 value in time, and you get these negative numbers. And for instance, here is about -8. So it ended, the Calanus season ended about 8 weeks before stage 1, or even in the water column. So this story starts to unfold where you start to see this most recent decade showing some of these negative values, negative overlap. And so the next question was, well, if we take that index and we average the decades, each decade, we take the average for that decade, what does it look like? And you can see there's positive value in this first decade, second decade, where I mentioned high recruitment year in the Gulf of Maine. You see even larger positive value. And then you come down to this most recent decade and it's a negative value. These are error bars here. And so if we look at the post-larval abundance, so the success of these guys making it to the post-larval stage based on new spawn catches in these same decades, and look at the average, you see kind of a similar trend where it's positive, come down to this most recent decade, and you have a negative value there, or sorry, a lower abundance value for post-larval lobsters. And then the next step that we took was looking at this at a decadal scale as well, but in a different way. So what this is those same decades split out. This is the most recent one here, except this is the proportion of catch throughout the year of both species. Again, these are the time periods, 2-week blocks here. And so what you see is in this first decade, you see Calanus kind of has this bimodal peak, and that's the gray. And then stage 1 peaks within the Calanus season. If you come to the kind of middle decade here, you see the Calanus season is drawn out for quite a period of time, and stage 1 peaks within that. In this most recent decade, you see that you have this increase in the spring, and then followed by this tapering, and then you have peak stage 1. So there's this widening mismatch evident both with the mismatch index and then kind of this method as well. And then next we wanted to say, well, okay, you see this widening mismatch, but what about the abundance? What does the abundance look like? And sorry, that's that secondary y-axis here. I'm going to start bringing up the abundance. And it's just the abundance of Calanus during the lobster larval season. And so if I add that in, you can see the abundance corresponds over here just during the larval season, which are these time periods. That's why it's a little shorter. The bar doesn't go all the way across because we really only care about what the abundance is when these lobster larvae are going to be in the water column or have the potential to be in the water column. And next, you can see in this second decade here, it's even higher. And then in the most recent decade, you see the abundance is much lower. In fact, there's a 70% decline in Calanus in that most recent decade. So this is kind of like a double whammy. If this is a really important food source for these guys, we do know they feed on them from some follow-up research. And if this is this critical food source that it could be for these guys, it's kind of a double whammy. You have this widening mismatch between the seasonality of both of these species, and then you also have this decline in abundance, which corresponds with this most recent decade, low recruitment within the Gulf of Maine. So what we have here is a summary. The correlation between warming ocean temps and egg hatch, but there's a correlation between warming ocean temps and egg hatch plus first appearance of stage 1. Calanus season has truncated in most recent years. Since 2010, Calanus season has frequently been ending before peak abundance of stage 1, with a net effect being an increasing mismatch of phenology of these two species. And then mismatch in recent years, along with overall decrease in abundance of Calanus, may be adversely affecting recruitment. These are the funding sources, Maine DMR and Sea Grant. And one more slide here for you. So yes, I would just like to thank you for listening. I'm super interested in all of this stuff. Obviously, give a shout out to Rick and to all the other folks that have helped with this work. And here's my email address. Please reach out with any questions. Love talking about this, and enjoy the rest of the week. And hope to see everybody at some point, hopefully the next one. All right. Thanks a lot, everyone. Bye.